Hello. Hi to everyone. So welcome to our channel. Till now we completed the Unit 1 7 chapters. So all videos are available in our mobile app. In the video description, the mobile app link is available. Then we are moving to the Unit 2 chapter number 1, that is the AC fundamentals. So in this particular video we are going to see the introduction about the AC fundamental as well how the syllabus related to the AC fundamental. Look at here. So AC fundamental, I'm going to cover 6 video lectures. In that 6 video lectures, the first lecture will be introduction and type of alternating waveform. This is a particular video based on the lecture number 1. In the lecture number 2, basic of AC generator and some definitions. Okay. In the lecture number 3, characteristics of sine wave, audio, radio frequencies, different values of sinusoidal voltage and current. Lecture number 4, phase of AC, phase difference, vector representation of alternating quantity AC through resistor, capacitor and inductor. As well as lecture number 5, sinusoidal waveforms and harmonics. And the fifth one, conventional problem based on this AC fundamental. This is a syllabus given from the KVS TGT work experience teacher, right? That's why you are moving to the lecture number 1, introduction. So in the introduction class, we are going to see about AC fundamentals. So this I will give the one waveform to you. Okay, this particular waveform, this is the time, this is the current, for example. Okay, in this particular waveform, the magnitude is positive, the current flowing in the one direction only. So that means that what is a DC supply? Just I will give the introduction about the DC, what we discussed up to 7 chapters. Then we are moving to the AC supply, because what is the drawback of DC supply, then only it is easy to understand the AC supply advantages. So in this case, DC supply only one polarity. Okay, one polarity is nothing but a one direction only. One direction is current flowing. As well as there is no frequency. It is one direction, there is no alternation. What about the frequency of DC supply? The frequency F is equal to 0. Frequency is 0. So the frequency of another unit is number of cycles per second. Number of cycles per second. So every point I mentioned very, very important in the examination point of view. So everyone maintain the running notes also. Okay. So in this particular case, the magnitude is a positive, either negative or positive. Only one polarity it should be, as well as only one direction in case of DC. So example for DC energy sources, that is a batteries, what we discussed in the 6th chapter. Batteries generate the DC supply, as well as DC generators. DC generators. These are the energy sources for DC supply. Okay. Now I will give another waveform to you. In that particular waveform, we can identify whether that is a DC or AC. Okay. So here, in this particular case, the magnitude is positive. So in case of DC, the magnitude is only one polarity, that is only one direction. Yes, it is only one direction. Means there is no negative off cycle, right? There is no that means if your waveform is from for example, waveform is for example, the waveform is like that, we can say positive magnitude as well as negative magnitude. But in this case, only positive magnitude, only positive magnitude, only positive magnitude. That means the time axis above the waveform is present. That's why it is not a AC waveform. Okay, it is an alternating DC waveform. Next one, third one, pulsating DC. Pulsating DC waveform. So we'll look at what is pulsating DC waveform. So in this case, this is the time axis. For example, this is a current. So the waveform will be pulsating. That means the waveform is available short interval of time. It is available short interval of time. Magnitude is present. Okay, this waveforms is nothing but a pulsating DC waveforms. Okay, next. Okay, next we are moving to the still no DC waveforms have a pulsating DC, alternating DC, and then straight line direct current DC. Coming to the AC supply. In case of AC supply, we have a alternating. For example, this is a circuit we have in the positive half cycle. Let me take this is a waveform you are connected. This positive half cycle connected to the load. This is the load we have. Okay, in this particular case, the current direction I will be flowing like that. Okay, in the positive half cycle. Now the same circuit, the negative half cycle case, what will happen? The polarity, the current direction, look at here, the current direction what we gave here, negative and positive polarity. So the current will be flowing through this circuit in opposite direction. This is the direction. That means previously I mentioned in case of DC only one direction. So now your conclusion, in case of AC supply having two directional. That means positive magnitude as well as negative magnitude. As a two directional, that is a positive magnitude and a negative magnitude. It is not only one direction. That means it is alternating, right? So whenever it is alternating, some of the peoples are thinking that the DC supply is a more advantage compared to AC supply, but don't think that. Every supply have their unique features, their unique importance. Let me take example. For example, I will take some transformer. I will tell you the importance of AC supply. I will take some transformer. The transformer connected to some step up or step down purpose here connected. In the 6th chapter I discuss about the transformer. For example, this transformer connected DC supply. Okay, whenever transformer connected to DC supply, transformer primary winding as like inductor, right? V is equal to L into di by dt. Whenever you are connected DC supply, what will happen? Current will be passes through the inductor. That is a constant current. DC is a constant current, right? Whenever constant current passing through the inductor, so whenever derivative of constant is equal to 0. So whenever voltage is equal to 0, constant current supply are given. So self-induced EMF in the primary winding L into di by dt. So in that here, in case of L, number of turns N into di by dt. So your derivative constant is 0, voltage is equal to 0. Whenever voltage is equal to 0, then it is nothing but a short circuit. Particular winding is the primary winding here, consider number of turns. That current is a short circuit current will be flowing. The particular winding going to be transformer going to be burned. Got my point? That means if you have a DC supply, but DC supply have some limitations. That's why we are moving to the AC supply. Okay, so this is the reason why you are moving to the AC supply. Now we are moving to discuss about different types of waveforms. Okay, we'll see different types of waveforms. So types of alternating waveforms. Here types of alternating waveforms, this is one of the waveform we have, sinusoidal waveform. So this is the voltage, This is a time axis, positive magnitude as well as negative magnitude. So this particular waveform is nothing but a V is equal to Vm sin t. For example, this is omega t sin omega t. So this is a representation for the AC supply alternating waveform. This is a positive wave cycle or negative off cycle. So this waveform obeys the sinusoidal waveform. That's why it is a sine term. I will explain. For example, let me take sine term, sine 0. What is the sine 0? 0. The magnitude is 0. Sine 90, it is 1. Sine 180, it is minus sine 180, it is 0, right? Next, sine 270, it is equal to minus 1. Sine 360, it is equal to 0. That means our waveform is varying with respect to the sine wave. It obeys the sine wave. Whenever magnitude is 0, see here, whenever the angle is 0, it is 0. It keep on increasing and then 1 and then minus 1 and then 0. So that's why it is a Vm sin omega t. Maybe this Vm value, that maximum value may be, for example, it is a 1 volt. Okay, 1 into sine 0, 0, right? Initially it is 0 volt. Maybe magnitude value in the second case, Vm is equal to 1 into this magnitude 90 degrees 1, that will get the maximum magnitude. Like that, this waveform is obey the sinusoidal waveform. Okay, that's why it is alternating. We are represented throughout our Unit 2 AC fundamentals, second chapter is the AC series circuit, everything we are using this particular concept. Okay, clear? Now, so this is only one sinusoidal waveform? No, we have different waveforms. Heading it's a different types of waveforms. Those waveforms we'll see. Okay, those waveforms we can see. For example, this is the time period. This is the voltage. Okay. So here, next type is a triangular waveform. In this particular waveform, the magnitude is varying like as a triangular wave. Okay, it is a positive magnitude as well as negative magnitude. This is a V. So another type of different type of waveforms we are discussing. Another type is a square wave. So all are AC waveforms only, but the variation of the waveform is different type, but it is a positive and negative magnitude, exactly same as positive magnitude only. Okay, so this also like as a square waveform. Okay, now some of the waveforms may be is like a sinusoidal, but some harmonics is also present. Like see here, this is a waveform. It is also AC waveform, but due to some harmonics is present. Okay, these are the different type of waveforms we have. So all waveforms what we discussed here, symmetrical waveforms. So these symmetrical waveforms only we are call it as a alternating. It is useful in the practical application. Symmetrical means that the positive off cycle magnitude is equivalent to negative off cycle, as well as the time period is always constant throughout the supply. The time period. So time period is nothing but a positive off cycle and negative off cycle. This is the time period. We will discuss all the points, time period and frequency, everything in the next further classes. Okay, all of you clear about all different type of waveforms? Let me give another waveform to you. That waveform you can identify whether it is a AC supply or not. This is a waveform, more magnitude. Okay, this is AC supply. Yes, it is alternating, but it is not AC supply, because in the AC supply the positive magnitude and negative magnitude both are equal, symmetrical, then only we are call it as a AC supply. Okay, this is not a symmetrical waveform. Okay, not a symmetrical waveform. So in our cases, symmetrical waveform only practically applicable. In case of, we'll look at another waveform is like only positive magnitude is only present, positive magnitude only present. So this is a, look at it, this is also not symmetrical, because if only positive half cycle is present, here positive half cycle is present, there is no negative half cycle. This is also not a call it as a AC supply, it is a pulsating DC, just now I mentioned. So this type of waveforms we have. So I hope that everyone is clear about the introduction, different type of waveforms, different type of power supply, like AC power supply and DC power supply. We have some drawbacks of DC. We discussed if you are connected to transformer, it is going to be burned. So that's why we are going to study about alternating waveforms, AC fundamentals, everything. In the next class, we are going to discuss the basic of AC generator. Thank you.